Hello everyone, and thanks for joining me again today. During today's session, I'm going to take a slightly different approach to my work on wyvern. Different in a way that we're probably not going to invent anything super new today, but instead I'm going to explore and see if we can squeeze more information out of the functions that we currently have. So during the last session, we managed to render these connections, and I'm very pleased with those, but we still have clashes. Fortunately, this is something that I had planned for, together with the fact that we would have to move, say, the right-hand side branch of question 1 if enough connections accumulate in the space between the left-hand side branch here and the right-hand side branch, so that the blocks are shifted correctly now. But now the second part of my assignment is that the gamma connections themselves should not crash either, or clash either with each other. I don't have a bulletproof idea for that yet, but during today's session, I would like to explore our options. And one of those options is, right now we keep track of the maximum width of the left-hand side branch, or of any block really, so that blocks positioned to the right of it can be shifted accordingly. However, we do not track the positioning of gamma connections themselves, meaning today they occupy the last or the furthest positioned or farthest positioned x coordinate block can accommodate for. So if you look very closely, this, and I'm very glad that these are vectors, this gamma connection is not positioned exactly in between action F and action 4. It's slightly shifted to the right, and that is because it is taking the maximum allocated space for the left-hand side branch of question A. It shouldn't be the case. Ideally, the first gamma connection that we formulate should go directly in between action F and action 4, and every subsequent connection should go 0.1 unit, whatever it is, to the right, and then another gamma connection goes another 0.1 unit to the right, and so on and so on. This is not happening today. And during today's session, I would like to come up with an idea how we could mitigate that. I think I have a pretty good idea, but I would like to test it. So, having introduced the idea vaguely, I hope you have your drink of choice ready. I got some coffee here. Where I live, it's temporarily sunny, but only temporarily. The day is pretty gloomy and sad and cold, and it has been raining for the last number of hours, so I hope you're in your cozy home or the cafe, wherever you're watching this, and let's add some more information to the functions we already have. So the function I wanted to enrich with additional information is this. So we currently already track the width of all blocks without any gamma connections. But this function, I believe we can squeeze more information out of. So let's clear this, not to be so messy and noisy. So what I'm thinking to add to this function is, instead of just tracking the max width a block identified by this ID can occupy, we can instead track one of two things. Either we can track a list of x coordinates, or a list of widths, in our case, because we're tracking widths, a list of widths every connection would take. So the 0th position in that list would be the width of the block itself. The first position in that list would be the width of the first connection, the second position width of the second connection, and so on and so on. You get the idea. And that would be a good start. But the second thing we could track instead is the same list supplemented with some sort of a true-false flag that determines whether a width was taken. And you might ask, okay, taken by what? Well, taken by the rendering engine, where we formulate gamma connections. Each width provided here could be taken by a connection. And if it is taken, no other connection could take it. And I think that's a pretty appealing concept. And I think I'm going to start from that option number 2. Not to track only the widths of the block itself and its connections as individual numbers, but instead to track a list of tuples, where the first element is the width itself as a number, and the second element is whether it was claimed by either a block or a connection, which will be useful later on during the rendering process. So what I'm thinking is only x coordinates for now, just to prevent these clashes. I do not, however, have an answer for these clashes, though, where two connections to two different points clash on coordinate y. They shouldn't be clashing like that. And if this connection is placed here, it should go maybe slightly below the connection f to question D or whatever this leads. Yeah, I don't even know. Right. That was a lot of talking for an introduction, so don't worry, we will be writing code today. But before we do, let me take a very quick break and I'll be back in a second. Okay, I'm back. So let's try to think of the type we could replace this with. We start with this, and we will need a list for sure of tuples of double bundle. And I think that is fine. This looks suspicious to me, but let's not do anything about it yet. Okay, let's take the plunge and change the type signature. No, I'm too much of a chicken to do this. Let's provide a new version of it. Let's call it version A. That way I don't need to refactor all of these. Okay. So this is ignored. Okay. So if I ignore it in this version, it should be fine. Mm-hmm. So technically this first lookup is not really needed. If we don't need the width, why do the lookup? Much nicer. Nothing broke. Sanity check. Okay, so let's go back to our function. And now this is going to be quite tricky. So for now, let's just return it. Okay. I probably need a better name than widths. Okay, so our situation is that we have this collection, and to this collection, we need to add So this should be an error. I don't need to show this. I wonder if this works. I think it should. Yeah. Good. It's red. Is it just a theme or is it an error? Oh, yeah. Oh, goodness. This is not a width. This is a pair. Here we don't need to worry about that. It looks a bit outlandish, but it might work. Let's see. No. Oh, that is a function, isn't it? This looks promising. So now, let's take care of the function that caused this. So we need this. The version of this. It will also end with an up. What we'll be inserting under that ID is not only the width, but also whether it's claimed. And in that case, it is, because that's the width of a block itself, so we can't use it. So I think you can freely ignore what I said about this line not being positioned exactly in the middle. What would be positioned exactly in the middle is the width of a block. Remember, what is rendered only takes like 80% of the width of a block. So the actual width of the block is in the middle. So the connection will probably not be there ever. So it's it will also always be skewed a little bit to the right. But still, I think this is skewed a little bit too far. It's +1, sorry, +0, 1, +0, 1, no, +0, 1, if that makes any sense. It worked. Okay, so the last thing we'll have to do during this session, and I intend to make this session reasonably short. I don't want to apply this function yet, is to just call it. glad we kept this. Widths of blocks and gamma connections. Okay. Who's excited? Oh, we need to change the signature. I thought we already have. Oh. Okay, we're getting something. Now, we just need to unpack it now. So under 1, we have a list of these tuples. Okay, so let's try to interpret this. So 15 is claimed by the block itself. Then we have 1, 2, 3. Sorry, 0.1, 0.2, 0.3, not claimed by connection. So it looks like, just a sanity test, it looks like 3 blocks have gamma connections that lead to block 1. Let's refresh our memory. 1, 2, 3. Do we have anything else? No. So this is kind of exactly what we want. And as we iterate through that collection, we'll be claiming the successful widths. So I don't want to go through this list, not to make any mistakes, but I think this will be claiming action 5. Sorry, not action 5. It's coming after action 5. That's action 6 here. This will be claiming the closest possible position to the block width. Action 7 will be claiming the second one. And finally, the third one will be claimed by action 9. Let's see if this is consistent with here. Yeah. Okay, I am excited. This is looking very promising. Let's just check the remaining entries. 6 only has, 2 only has 6, fair. 3 only has 6, also fair. 6 also has, only has 3, that's fair. A, I think, should have something, yeah. A has 9.1 unclaimed and 9 claimed. So we should have, we should have 1 connection leading to A. Let's confirm. A is here, and that's 1. Let's see, the right-hand side of question A is leading back to A. Let's confirm. Right-hand side of question A is leading back to A, which is, I think, action E, if I'm not mistaken. No, question D. Question D ends. And we have action C, question D, and then we go back to A. Action C, question D, which branches out, and then we leave, we go back to A. Okay. Now, what will be a problem is that these two connections lead to different blocks. And if we're tracking whether something was claimed, we only associate that claimed status with a block. So we can still have two different connections leading to two different blocks claiming the same width. So I think we'll need something more global in scope when it comes to the claimed status. But I think the idea is appealing, and I think it is sound, at least for now, to stick to it. All the rest of them are just... Oh no, D is also 6.16. True. So my current thinking is this claimed status is a very appealing idea, with and claimed, but two changes are required, I think. One, a global scope, not a scope allocated to or associated only with the block as a destination, and also we shouldn't be tracking widths, but instead coordinates. So let's take a note of that. And we can update that claimed status in here in the render function. And once we have a global table of claimed statuses, oh no, that also wouldn't work. But I wonder. No, the width-wise, we should have enough room. So let's run a quick experiment. Let's try 3. I'm just trying to check if those widths combine. And what I mean by combine is the width of this, which would be, or width of this question, which would be increased by 3. let it be combined with the width of question A. So let's try to quickly calculate. Question A normally would have 3, 6, 9 width. One connection leads to it, so it has 12. But since this one is also extended, it should be 15. See? It is 15, yes. But it used to be 15 as well. Oh, sorry, A. A is still 9. Where's that? Oh, because we never changed it. If we do 3, it used to be what, 9? So I'm expecting plus 6, 15. Let's see. Yeah, that's good. That's 12. And now it's 24. How come? Let's calculate. 12, 15, 18. Where's the other 6 coming from? Oh, because there are still 2 connections, 3 connections leading to it. No, it's fine. A width is 12 because we have that connection, plus 3 because we still have what am I looking at? It's 9 plus 1 connection, that's 12. A 1, 2, 3 plus 1 connection somewhere here. So should I be checking? The width of question D and question A. Okay. And D is 6 plus 1 connection, that's 9. Yeah, see, that's the problem. D's connection is scheduled for not scheduled allocated for 9 with D's width is 9, but A's width is also 9, but the origin is different. But origin does not come into play. A's width should be whatever the width of D plus all its connections plus its connections. But it's 12. Oh, so, you know what? This might actually be correct. Let's take a cheeky screenshot. Because that's the most scientific method I can think of. This would be 3. So this is roughly a space allocated per block. 3. It looks like I'll have to think about it some more. But this doesn't look correct. There should be one more of those 3s. So the first connection should be somewhere. somewhere here. Yeah, according to my calculations, this should be the spot for the second connection. Yeah, so we discovered the problem with the max width. I'm going to save it. But after the recording is over, for now though, I would like to thank you all for your attention today and for your patience. Upcoming sessions should be pretty interesting. We should be able to resolve that problem with parents width being the width of its children plus their connections. I don't think we're factoring that in today. And also, we should be making some progress on the global sort of our global coordinate axis being claimed by connections and blocks or not. So there's a lot to unpack that will keep us busy for days and days. I hope you have a great weekend ahead, and I wish you all a fantastic time, and take care of yourselves. Bye.